Awesome. So let me start out by saying this image I selected of sentient robots is not the scope of this talk. So I want to be very clear and transparent. This is not about science fiction. And actually, I'm not going to talk about core AI technologies such as speech recognition and understanding. But what I'm going to share is related to my expertise in interaction design, specifically, and as a design professor, but also design consultant, and actively working in many different clients around the world, my focus is on two things. One is AI as a functional material. So we have different technologies that we work with as designers, and there's a bunch of kinds of experiences you can create with intelligent systems. And that's one topic, and completely orthogonal to that topic is how AI is used in a generative case to do design work, or maybe even replace designers. So maybe at the end of my presentation, some of you will think, hey, might be time to retire. I could be replaced. Or maybe you'll think, hell no, I can't be replaced. This isn't a convincing case study. So before I jump in, and particularly a topic like AI, I want to follow Voltaire's advice, which is to define my terms, because it's such a broad topic and so misused in the press. So there's four kind of dimensions of the definition for AI. I want to be really clear about the language I'm going to use. So the first set is about hard AI versus soft AI. Hard AI is basically when you're using neural net technology and everything is completely non-structured. And an example would be a photo recognizer that can tell the difference between cats and dogs. And generally, these systems are not explainable. Soft AI is primarily based on machine learning, and you're dealing with massive knowledge bases. There can be specific rules and statistics applicable. An example here would be the Amazon book recommender. It's really working on a lot of data, and it is in fact explainable. Amazon doesn't show this to you, but they have good reasons for recommending what they recommend. And it's debuggable because it's explainable. And then we have historically the expert system area, where we have human beings who are knowing how to do a task, and we try to build a digital system based on domain rules and historical data, and have that function instead of a human being. So an example would be a diabetes management solution in your mobile device, where it's kind of acting like a diabetes coach, but there are domain rules for different levels and treatment strategies associated with diabetes. And of course, it is explainable. Now, a working system might use more than one of these categories. They're not mutually exclusive. The two case studies I'm going to show you fall into the soft AI category. And one note of caution here, while I am going to talk about explainability, by default, explainable does not mean that you're getting a correct result. It just means that you could trace how the result was created, because there can always be gaps in the underlying training data or any structured knowledge base. The second dimension definition is the degree of human agency. Some types of automation are to replace humans, like the self-driving car. Other types of automation are for augmenting human capability. And here I have a picture of the Da Vinci surgical robot. So there's a tremendous amount of intelligence in the system, but in the end, the doctor is in charge of the surgery. The third dimension to the definition is the degree of risk. So in a very intelligent system like a human exoskeleton to be used in a factory, has fairly low risk. Self-driving cars kind of in the middle, and autonomous weapons are pretty high risk, to say the least. And so there's a difference in the two case studies. My first case study, which is going to be medical application of AI, is pretty high risk. And if it gets it gives you a wrong answer, it's very bad. The second case, where we use AI to design user experiences, is a bit lower risk. And a fourth way to look at this, I draw from Ben Schneiderman's Human-Centered AI book, which I highly recommend to everybody to read. It really helped me clarify how I think about such a broad field. Is Ben basically says you can divide it into systems that behave in 4 ways: an intelligent agent, self-driving car; a super tool where humans in control of the technology, but the task is not doable by a human being alone. My first case study will be in the super tools category. And then where his third category is where the AI acts as a teammate. So there is some human-like creativity, but it's really collaboration with the AI. And then the last one, like the intuitive surgical, is a telebot use of AI. So now I've kind of told you where my case studies position. Let me jump into the first case study, UX for AI. Now, everyone should be familiar in terms of the viewers with things like the Amazon recommender function, right? And this is again done on a bunch of big data and basically surveillance of you as an individual, deep surveillance. So if you go back to my definitions, the AI class is soft. The agency level is to augment your shopping experience, but the risk level here is 0. If Amazon recommends a bad book, the patient doesn't die. And of course, you're surrounded by this all the time. But I'm going to show you the extreme version of this. Case study 1, rare and undiagnosed disease analysis. The input to this activity is the DNA and RNA whole genome sequencing of usually parents and a child. You're most interested in the child and sometimes the siblings. The process is, once you've sequenced the DNA, you have to have every unusual variant appear. You have to map every variant to possible phenotypes. So a disease characteristic, which could be a blindness or deafness or some maldeformity, and figure out, once you can determine the diagnosis, that is the first step in leading to what your treatment options are, be they genomic or non-genomic medical options. The typical user has a PhD and a lot of expertise. And the goal actually seems simple, which is there's an ordering physician who says, I want this human being sequenced so I can figure out what's really going on and figure out a treatment plan. So the end result is actually a report. Now, I'm going to show you just some screens to orient you in this. You don't need to know too much about genomics. I'll highlight the points I want to reference. But if we go back to those definitions, the AI class, again, is it's kind of soft AI, lots of different knowledge bases. Agency is to augment human intelligence of a very highly trained professional, and the risk level's high. You're looking for a needle in the haystack, and you don't want to be wrong. If you looked at this screen, this is the case screen. So each row represents a case, which would have sequenced at least one parent and a child, usually both parents. And here you can see the phenotypes. So phenotypes could be high palate, short neck, deafness, blindness, sickle cell anemia, right? And so you're kind of mapping that. Now, you go one screen deeper in and click into the case, and the AI behind this has basically said, okay, based on all of the variants that you're looking at in the human genome, what are the most likely gene variations that are not normal, and all the data. So it's basically saying here on chromosome 17 at this position where we were expecting a G, and if you remember your high school biology, you have A, C, T, and G, right, is the 4 DNA pair types. We expected 1 G, and we're getting this entire string of insertion. So this is a big insertion in the gene pool. Over here, we're seeing a substitution in chromosome 7 at this location of a C where there should be a T. And we're also seeing that. And actually, this element on the left, MY01C, is an actual gene within chromosome 17. IMPDH1 is a gene within chromosome 7. Now, you have, look in the bottom corner here, you have 46 chromosomes, you have 25,000 genes. In a human being, there's 3 billion pairs of DNA. And in a healthy human being, you could see 100,000 mutations from a reference genome. Then, of course, you can go into the details and the analysis tools yourself. But where you're trying to go here, right, is, all right, given all these variants, if I look at the details of a variant, what is its clinical significance? And what are the related diseases? And is this pathogenic? And there's lots of things to consider. And you're looking, whether the mother or father is, and relative to this variant would be considered heterogeneous or homogeneous. And so which ones have and don't have, and do they have the same? Now, given all of this data, you have another situation. The number of places that are being referenced, all right, each of these blue things here is a knowledge base. ClinVar is a huge US knowledge base. Each of these knowledge bases has millions and millions of records, including every scientific article, clinical trials, and publications from all of the leading medical institutions in the world, and most of them are sharing their databases. So now, in addition to 3 billion pairs, hundreds of thousands of mutations, the knowledge bases are changing underneath you every day. So how does the system come to its conclusions? Well, it's a lot of very impressive software engineering and AI. But what I do want to point out is, if you ask to see the evidence for any one recommendation, you will see the graphs that take you through the types of variants for this gene. There's some dysplasia known as a Silverman handmaker, which obviously relates to some famous article, et cetera, et cetera. And again, multiple publications changing every day, clinical trials, drug labels, the population database changes. You have to take into account ethnographic data, because a variation in a Caucasian might be of concern, but every Asian person has that variation, and it's not known to ever be pathogenic in their gene line. So that is all of the AI that ends up in a relatively straightforward clinical report to the doctor, who then can proceed to an official diagnosis. And so this is basically where this ends up. Now, the discussion topic, and I meant to get rid of the word student. I've used this in university lectures. Sorry, I missed that earlier today. But what's the most important characteristic that as a UX designer you have to achieve in a situation like this? And if anybody would like to come off mute, I'm looking for a one-word answer. Okay? What's going to make somebody use a system this complicated? This took a long time to build, and this is in the market. Imagine is a subsidiary of Illumina, which is the largest sequence maker, instrument maker in the world. Anybody want to offer? Come off mute. What do you need? What is the characteristic that this software has to do? I can also look in the chat, I guess, if somebody wants to offer an answer.
If I understood it right, looks like that it's trying to do a prediction.
Correct.
And this prediction can cause a very, let's say, severe, or can show severe results. which are critical for the patient. But it's still in the back end, it's a calculation based on some historic data, which not necessarily have to be true. So what we see here is, it may be a result, or it shows maybe a very critical result, which we honestly can't say that it's going to be true.
That is correct. And truth, and basically the word I was looking for, that starts with a T. I was looking for the word trust, right?
Yeah.
Somebody has to, you have to trust that this system knows what it's doing, right? If you didn't trust this, then what's the value of the report? And the answer is it would be zero. Now, the system is making recommendations. The PhD in genomics produces the report. They can abstract from what the AI tells them, and the AI can tell them, I don't know if we can go back a screen or two here. It's not, I'm not sure that I have it in here. Yeah, so basically, if you look at clinical significance, the ClinVar knowledge base doesn't have any information. The HGMD doesn't have any information. Only the KMS database basically says this is pathogenic. It is absolutely possible that these knowledge bases disagree, right? And in which case it is the user, the genomics PhD, who's got to sort through all of this and say, okay, I think this is a relevant finding. And it's primary, it's secondary, or it's tertiary, and give that information to the doctor, because in the end, it's the physician who's practicing medicine, right? So this is really the big deal here. So what do? You have a lot of testing for these systems. You run known cases through them and see if they agree, right? So you have a lot of training data that says this data indicates a certain thing. And if the system doesn't say that it does, obviously you want to keep tuning. But there's some risk here, right? So any questions about this? But again, the main thing about this particular application is, unlike maybe the Amazon book recommender, where you can ask your friend to recommend a book, it is not possible to do this task without AI, right? No PhD, no matter how well-intentioned, can stay up with the literature and the changing databases or process this much information without some automation support. So any questions about this case? This is the media, right? Just design a competent UX for a smart system of high risk.
Dan, another comment in the chat is transparency in how system has reached this conclusion. So I mean, that kind of is going back to your idea of trust.
Right. And that was primarily about the graph, right? So when the system makes an assertion, it literally says, I'm making this assertion in this graph. And you can follow the graph. If we go back to here, right? Some of these will be articles. It will take you to other cases, right? But if you click in here, it'll say, I think this connection is indicated in this particular article, in this particular journal, in this particular case, right? And so the genomicist, if they're not familiar with the article, they might stop and take an hour or two to read it before they decide to include that this is relevant in the report. Okay, so for the sake of time, let me go on, because the next one is probably a little bit more mind-bending than the first one. AI for UX. So can an artificial intelligence do your job? Well, there is proof that it can, and the proof is not theoretical. There is a software company that I've been involved in, though for full disclosure, I am not a founder. I am on the advisory board, not even the business board, called Clean Software, Kleen. You can look this up. Products in the market. And it's going back to my definitions, it's soft AI, it's to kind of augment, and the risk level is sort of moderate. And it's part of this whole low code, no code idea. But effectively, the concept is the user explains what they need to do, right? And there's a pipeline of models and AI techniques that design the user interface, and it also codes it and exports it to the cloud platform of your choice. And if we go a little further, okay, I'm kind of talking ahead of my slides. It looks kind of like this. This is kind of the pipeline. And when you deal with like all of the different files and data, there is a graph that's constructed about data relationships. And then there's a graph constructed about human goals and design patterns and how to map those patterns to create a user experience. And so there's more than one type of AI involved. Now, to step into the real world, take a look at these screens. This is a completely AI-generated user experience, fully functional. This is a use case for vehicle fleet management. So it's not a super complicated case like the Genomics example, but by specifying the requirements for this system, the AI created this working prototype and wrote the code and put it in the GitHub. How is this accomplished? Well, there are multiple models. These diagrams are just placeholders. I'll show you one real diagram, but just understanding that there's lots of different knowledge graphs. So what you have to do is you have to map the semantics of the interaction design, and I will clarify what I mean by semantics for those of you who haven't read my book, and just a little bit, the workflows that need to be accomplished, and the personas who will interact. Then you basically take the semantics, workflows, and personas, and they have to be mapped to the business logic, and you have to select your visualization patterns. And then you have to map everything to a UI library, to a language. By language, I mean English, Spanish, German, because this can operate in any language, and to some visual design themes and generate the code. I can explain and answer questions about this part a little bit. Now, how does this all work? The underlying model and semantics come out of from a book that I published. Actually, I think it was in 2019, but 2020 is good enough. On semantic interface design. The title of the book is UX Magic, which is a sort of a fun name, but it comes from a long history of work on how to model user interfaces, ranging all the way back to Phyllis Reisner in 1979 at IBM Watson Labs. And the core idea is to describe a conceptual model for the experience before the experience. And that was first documented in 2012 by Jeff Johnson and Austin Henderson, and kind of the first layer. And both, if you're not familiar with those names, they were both members of the original team at Xerox PARC that invented the graphical user interface 3 decades ago. My approach basically was to extend from this notion of the conceptual model, which is a grammar of objects and actions that I'll speak about in a minute, to map that to visualization patterns, flow patterns, and game theory patterns. But the game theory is not relevant for the purposes of this talk. So what do I mean by grammar, right, and semantics? All user experiences can be described in advance as a set of actions, objects, and attributes that human beings understand when they're shown on a screen. Actions can come in the form of menus, they can come in the form of gestures. But again, in a graphic design product, like say PowerPoint that I'm using right now, I would consider a box an object, and an object has a bunch of attributes. If you go a little further, you can basically pick apart any existing user interface. And here's Facebook, right? Where it has a bunch of global actions in the header, some local actions down the side. Content is an attribute, and basically people and conversations, posts, are the primary objects. And then they have a bunch of different things happening in the left side panel, which is always a mess because it all looks the same. But how they divide or want to divide the world into objects versus actions versus attribute filters. So if you understand that all user experience can be described before it exists by the objects and actions that comprise the tasks that people want to do, you can basically build a table, and a very dense table, like all the actions I have are cut, copy, paste, and they apply to all my objects, like in a word processor, will result in fairly linear growth in cognitive load. But if you're really sloppy in the conceptual model grammar design and have a lot of redundancies, duplications, and exceptions, actually cognitive load will grow exponentially. And one of the things that's interesting is, and I teach this in my classes at San Jose State, and also classes for Rosenberg Media on how to apply this technique as a designer, this is a place where the AI can actually outperform the average designer by figuring out the most compact representation of grammar and then design from in this linear world almost every time. So it absolutely outperforms junior level designers in figuring out the conceptual model, which is the first thing it has to do before it can choose the screens. And then it goes to the flow level and plans out the flows. So just here are a few screens from the authoring environment that you collaborate with as either a product manager, a designer, or an engineer. And you define, and this is going to be for a bookstore, what are the workflows you want to have. Maybe you have a workstore for a workflow for defining genre details, or a workflow for choosing departments or configuring the book. So you have workflows, and for every workflow, you have to identify what's the persona. And going back to what I explained to you with regard to conceptual model, what are the actions and objects? Here they use the term verb. And a thing is a type of data and generally an object. So the terminology here is not exactly matching the book. It's the terminology the founders chose to use, which I'm not happy about, but it still works. And then you select the type of experience, and you can have some specialty things associated with the experience. But generally, experiences are either about enumerating the data, gaining understanding, so maybe pushing you towards a dashboard, or you can sort of be more specific and create your own. There is a catalog of things. This is actually the database schema. Some of these may be represented as objects in the UX. Some of them are just attributes. But the software does need to know the entire schema in the APIs for getting and putting data. It generates a graph of the data relationships that it's going to use. This is a real graph, unlike the ones in my previous slides that were kind of placeholders. This is not a graph calculated by the AI. It's a graph of the AI's understanding of the relationships in the data that it can deduce from models that you feed in. Might be your database schema, might be your API definitions. In the end, it takes all of this, the requirements that you have postulated in the form of objects and actions that take place on those objects and the types of flows you want. It generates a bunch of code. It pushes that code into its own selection of UX patterns and connections of those patterns. And then you can run the prototype without a back end, or you can just export all the code to GitHub and run it. And we had this bookstore example. Here's one of the auto-generated screens for the bookstore example. And there was no action on the part of the designer that said, add a new book. That was deduced by the AI. It figured out, based on the goals that were identified in the personas, that at least one type of user inside the bookstore for managing the collection or more would have to add a book. And so it would generate the add book screen, which might be import, it might be manual typing. Then if you kind of apply the logic in the UX Magic book and look at the visualization layer, right? The visualization layer, we have raw components like buttons, we have different kinds of widgets like forms, and we have page archetypes. An archetype would be a dashboard versus a social feed pattern like Facebook, and a bunch of other elements. But fundamentally, I'm going to just show you a little bit about widgets. So you can go in and work with the AI to build widgets. And what you need to explain is, what are the requirements for the widget? What is the desired insight and functionality that this wizard would need to express? And once you say, okay, well, we want a widget that's going to work on order status, and our goal is to predict future orders, or the goal is to figure out profitability, etc. You basically explain your requirements in natural language, whether you want aggregation, a few other details about how you want things ordered, and in the end, it'll give you a preview, and it might say, okay, to figure out what you just asked for, I'm going to give you a bubble chart. And that widget was, and the relationships of the data and the data viz definition of the measures and dimensions that drive the chart were all calculated and by the AI. So it made those decisions. There was no direction. You only explained the requirements for the widget, what goal it would have to achieve. And then, of course, when it comes to generating the entire UX design, the AI will go pull that widget and put it in the dashboard in the place that it thinks it's most applicable. And it also generated the report view, and it generated sort of the inventory view as well. So that's my quick tour. And again, this is really part of a larger movement. I've worked with a number of startups inside this movement related to the low code, no code. Can you take work that used to require engineers and create a user interface so a product manager can actually do it? And can a product manager actually do it instead of needing a UX designer? So this whole automation in the world of generative work in technology from beginning to end challenges the assumption of where will designers and software engineers be employed in the future if we can really have these smart systems. And that first vehicle, fleet management set of screens, that entire system was created in a half a day, from idea to inputting in all the requirements to playing with several different prototypes, picking and cooperating with the AI to say what you liked and didn't like, and then deploying to GitHub and having working code. And there's no developer or UX designers that could do that whole thing in half a day. So we'll get back to the question of where people employed and what your future careers might look like as this automation creeps out further and further up the food chain. But now, again, a question for everybody. What's the obvious weakness? So I've shown you this system where you describe the requirements. It basically implements the UX magic book and a whole lot of other ideas and generates the UI and generates the code. So what's the Achilles heel of this system? So again, please come off mute and let's have a conversation here. So Max.
Yes, I think it could give you some result that you have no idea or understanding of how it came to that answer. So it's sort of like if someone is insane or immoral, that's one thing. If they're amoral, so you could get an asane answer from your AI.
That's true, though you have a way to, a very traditional way to figure out whether it's a good design or not, right? And that is you just usability test it. And if I can generate 10 different designs in a day, I can show those to the expert users or consumer users, and I could get feedback as to whether they work or not. If I can't show you the knowledge graphs that are inside the product, some of them are interrogatable, but not without an NDA and having, a paid license for the product. But there's a bigger problem. But that yours, Max, also goes back to trust, right? How do you know, right, that they're rational recommendations? And in this case, there's a plurality of right answers that could be valid and be usable. In the genomics one, there's not a plurality of valid answers, most likely. There's a specific diagnosis. But what else is a problem here? Anybody want to?
Yeah, I think you need to bring in all the different objects and relationships which are required really to cover the whole use case.
Yeah. So that's basically where this sits, right?
Yeah.
Garbage in, garbage out, right? If you don't bring in all the relevant information, then you have very rapidly, and then maybe it's good, rapidly created a UX that might be usable, but it doesn't solve the problem. Agreed?
Yeah.
Right. So it's only as good as the person who can define the requirements. This is still a problem, at least for me as a UX designer, that the quality of requirements that comes in are always incomplete and ambiguous, even if the quality is high. Most of the time, the quality is quite low. And we're often doing UX design to explore the requirements, even before we're doing UX to build something. But this is a basic issue, right? And now the second question is, will AI ever be able to solve for this Achilles heel of garbage in, garbage out? Would anybody like to offer an answer? Or
I
vote?
think it's very, very situation specific.
Okay.
Therefore, very hard to get such a huge database which you really can use.
Right. The AI would have to basically look at the requirements and say, you're asking for something that's irrational or stupid. Right?
Yeah.
I say that to product managers every week. Right? You're asking for something that's irrational or conflicts with all the goals of the product. But I don't know how to say that. I just know that if they don't like it, they'll fire me, and I don't care. But I need to be honest about it. So I have to be truthful here. I don't have an answer to this last question. I would say if it's solvable, it's probably not in my lifetime. Maybe it's not solvable. So then what does that say about how everyone's careers would be affected by the two sort of megatrends that I've shown you these case studies for, right? UX for AI, which is just how do you design a product that has a lot of intelligence in it and needs a good UX that people trust and can verify, versus how can an AI actually replace some of the day-to-day activities that designers do? I think that there's some consensus on the second one, but I'd like to hear people's thoughts. We still have time. So what do you think this says about the future career? And, you know, some of you I can see look like you're more my age, so you're not really worried about this, but there might be some really young people who are just starting out or mid-career. So what advice would you give, or what action would you take? Change careers, or maybe change how you practice? Question is open to the floor.
I think with the students, they're really open to sort of new ideas and doing things, and they could just see this as a yet another tool, a very powerful tool that they can use, but they still have to use their sort of critical thinking skills and you know, work on that part of the equation as well with the students.
I agree. Anybody else want to comment?
Just a thought, Dan, is that you know, one thing that came to mind is that, oh, this might free designers from maybe being kind of tied to the pixels of the page or the pixels of a project.
Yeah.
But of course, it goes beyond that, right? So then, you know, if a designer is freed up from that, you know, what are they then doing, or, you know, what does that maybe give them more time to focus on?
I think the general consensus in the profession and in the education community is automation is always increasing, and that for students of HCI and for designers, et cetera, it's really about up-leveling, right? Because that Achilles heel still exists, what we really need to talk about is becoming full-service product designers. Worry about the product design, let the AI do a lot of the mechanical stuff and the grunt work. And again, as I position this tool, it's a collaborative tool. You work with the AI to co-create, right? And so the AI can do things in seconds that would take you weeks. And you can, again, test and throw it out. It can give you, the AI will actually present you alternatives. It doesn't say there's only one answer. It's better than that. It's going to say, here's a couple of ways that we can do this. These would be the most, we think, you know, it thinks the most commonly understood and most efficient. And you can tell it, I'd rather see an option which is kind of half of part A and half of part B. What does that look like? Click. And within seconds, you have a prototype, which you can use in a usability test and try it again. So I think it's really about up-leveling. I don't think, you know, I don't think it's about just brute force replacing labor, though I would make one editorial comment here, which some people might not like, but right now, clean software and its competitors, right? I don't know the mechanics of the competitors, but I know they're not the only ones in this field, can outperform your average General Assembly bootcamp graduate easily, because those are very tool-centered programs, and it's all about how fast you can work in Figma or Sketch, and it's not a deep analytic systems level thing. What we need for designers to do is be very broad systems level thinkers about what are in fact the requirements and how can I accurately describe an almost complete set of requirements, and move up the food chain. And that's more typical of what you would see of a graduate school education program, as opposed to, you know, 8 weeks ago, I was a real estate agent and now I'm a full service UI stack designer. You can't compete with the AI with that level of education. And so I do think at the bottom of the food chain, there will be some displacement, but there will be lots of opportunity at the top of the food chain for people to up level. So we have a few minutes left, and I'd love to hear everybody's thoughts about this. Is this what you expected today? Are you surprised that the generative capabilities are as far advanced as they are in what I demonstrated?
Most definitely.
This product, yeah, go ahead.
No, I just see this as like a really useful tool for like my little startup. I just have, me and a co-founder and something, as a product designer, manager type person, I could probably go and use one of those things and use it to generate the what we need now for our next level of mobile app.
Yeah, this does solve a scarcity of UI designers problem. Particularly, it's very focused, to be very transparent right now on enterprise applications. So particularly internal IT departments have very few resources, and they always have trouble competing for UX talent, right? And they have a huge backlog of internal apps. So we see a lot of uptake in university IT departments and corporate IT departments, where the AI really understands, and those patterns are fairly cookie cutter. And so again, it won't be doing the genomics thing in my lifetime, probably. But there are just a massive backlog of apps and simple cases where maybe like yourself, you don't have the resources, but you can explain the problem. You could sit down and learn the product in a day and explain what you need and see what it produces, right? And it's all cloud-based,
Exactly.
right? And you don't have to pay for much. But one of the things it does understand is it understands themes. You can use any UX design library you want. You can use React, you could use Material. It understands themes and styles, and it understands accessibility and internationalization. So it writes very, very good code that will scale. It's not a toy. And there are, I don't know, I haven't talked to the CEO in a while, but I think at this time there are dozens of companies using it. It's been in the market for almost 2 years. So any other questions?
Shirish, yeah, I have a question. Can you hear me?
I can. Can you come on video so I can see you?
It's midnight, so
You're
not. Yeah,
Okay.
I would not like to do that. So question is, you several times you have mentioned that there are multiple solutions. Is there any solution where it considers end users' personal preferences to come up with its own specific UI, not a generic one that in this example you have explained?
Generally speaking, no. It's not generating UX designs that could learn from the actual end user behavior yet. It can generate UX designs that are configurable by the end user. So for example, when it generates a dashboard screen, it can put a little gear icon up and say, I think these are the 5 portlets that are most valuable, but here's the entire library that I've generated, and you could, change it. So it could do things that are configurable, but it's not fair to say that it's smart.
Yeah, that answers the question, but I'm just toying this thought, if whenever it is possible, then we are not basically talking about multiple variations of design, and then we are going to the end user to validate which makes more sense.
No, you could ask for multiple. You could ask it for the 3 best prototypes it can generate or more. And you can go as a user research activity and have your users try all 3 different prototypes and give you feedback. So while it's generating effectively a monolithic solution, and in a prototype, it can create variations. But now it is up to the author to test them and then give guidance back to the system on what seems to work and what doesn't seem to work. And then it can iterate again.
Thanks, Dan.
Okay.
So next question then is follow-up. Do you think soon system will become intelligent to consider these personalized preferences to come up with a specific UI?
I think the answer is yes, eventually. And I say that not because of my work with this startup, but because of my work with another startup that is developing the tracking and understanding behavior based on the semantic model concept. So here we're using the semantic model per the UX Magic book for generative creation of a UX design. However, you can actually run the mathematics backwards and look at clickstream data and map it back to a semantic model to see what people are doing. And that project is underway with a nicely funded startup. And if these two startups got together, which I might arrange when we get a little further with the second one, and can really prove at scale, you could combine the two and maybe do what you're suggesting, Suresh.
Yeah.
But
Now this is
you need the
bit
model,
scary.
you need the back end, you know, the model.
Yeah, correct. Yeah.
The
Yeah.
decoder.
Now this is a bit scary, I'm saying.
Yeah.
So I had a question, not a question, but a thought, Dan. This is Angad.
Hi, how are you?
I'm doing fine. Thank you so much.
Nice
We have an application called Intersight, the product that my team and myself support. And we recently integrated with Full Story. I don't know if you're aware of the tool.
Yeah.
And we're just starting to learn from Full Story from various different users. And basically, we're eventually being able to map it to the personas to be able to see how these users or these, are using specific capabilities within our product, right? So even UI is generated by us and we put buttons here or additional link over here and so forth. And we're basically starting to capture and see what are the behaviors there in terms of, interacting with the many different interfaces that we have. And I think where this could lead in the future is the system being smart enough to learn from the user's behavior by interacting through the system and being able to offer them a more sort of created user experience. Again, it's very much, as you said, it's not going to be, we still are in the age of the cookie cutter model here with specific use cases, how this will interact. But I think if it could predict the UI based on learning from that behavior, I think that'll be very powerful.
Right. The issue with things like Full Story is, again, it's still kind of, in my mind, an analytics dump. It tells you what the user did. It doesn't tell you what their goal was.
Right.
Right. It doesn't watch them in multiple sessions over time to learn their behavior in terms of interaction design, as opposed to learning their behavior for e-commerce purposes and upselling. Right. That's a completely different kind of knowledge graph than what was the user really trying to do? What were their goals? As opposed to what did they click on?
Right.
Right. Yeah. Okay. I think we're at a minute over. I don't mind staying a little longer, but I'll leave it to you, Dan, Colin.
Maybe we just have a quick call for any last questions.
Feel free to reach out to me. I am available. You can find me at my website, rcdous.com, just Dan at rcdous.com, or my university email address is easily discoverable too, at San Jose State. And I'll be happy to continue the conversation with anybody. And if you have some interest in applying any of this, reach out to me and I can get you pointed in the right direction. And I wouldn't charge for any of that.
Thank you so much. This was excellent.
Yeah, thank you, Dan. This
Thank
was
you.
a super illuminating presentation, and we really appreciate your time and coming and sharing with us. So this concludes the Design Bites then for today, everyone. And thank you again, Dan Rosenberg. And we'll see you all again. Look on the events calendar at HANA House. Check Eventbrite where we publicize these events, and we'll let you know about what will be coming next. Thanks, everyone. Have a good day.
Okay, bye. Thank you.
Thank you. Bye-bye.